Okay, so let's check a few things together. So first of all, you need to get 3 handouts today. Check it. Did you get 3 handouts? You need all of them. So the first one is the solution of homework 10. The second one is sample questions for the final. And the final one is the final exam of the previous year. Do you have them? Okay, if that's the case. Let me show you this. Here's the group assignment. Okay, so let me click this. You can find it in the assignment section. So I just made a group for you. And the purpose is to study together, especially these final exams of the past, okay? And then as a group, you're going to present solutions for the entire class. Okay, so you have to get together and hopefully you help each other and write a good solution and let others know, okay, how you solved it. So that's what we are going to do in the next week. So please find your group. I'll give you 3 minutes, okay? So find your group member and maybe you can exchange your telephone numbers, okay? Just say hello to each other. So why don't you do that? There are 16 groups. Okay, listen carefully, okay? For these sample finals, I'm not going to give you my solutions, okay? So there's no official solution. So the entire class will depend on your own solution. So if your group is assigned to a certain thing, you have to make sure that you present the correct solution.
So is the problem will be appear on the final exam?
Yes, very likely. With some changes. Okay? Now let me assign the questions to you. So some questions are easier, but some questions are harder. Okay? But at least it's kind of random. So if you happen to have harder questions, please don't blame me. So that's the assignment.
So this is coded also? Is also coded like the presentation?
No, I'm not gonna grade it.
All right.
So your own incentive is,
Yeah.
I mean, you're kind of responsible, okay, for this part. So if you don't know how to solve it, then the entire class don't know. So in the next week, we'll take our time and we'll do this very carefully. So you can do it right now. You can start today. So most likely, these 8 groups must be ready by Tuesday, okay? But I think we can do more. So to be safe, everybody should be ready by Tuesday. And if there is a few questions left, then maybe we'll take care of it on Wednesday. So is it clear? Now this is my plan. So today's lecture can be the last lecture for the semester. I have 1 left, but that depends on our problem-solving session. If you can do everything very early on and have maybe 40 or 30 minutes left on Wednesday, then I'll do the next lecture note 2. So currently, the lecture note today is day 23. By the way, the exam is up to this, okay? So the final is up to today. So whatever you do next week, it's not included in the final, okay? If time allows, we'll do the next one. If it doesn't, then that'll be it. Okay? So in some sense, today is the beginning of your kind of final season. So you have to be prepared because, I mean, in that week, you're going to be crazy. You're going to be extremely busy. One announcement is that from the syllabus, you may remember that there's a final paper, right? So that is my original plan, and I was thinking about it, and I decided to drop it. So there's no final paper. So I think it's just better to do a few things better than just getting into too many things. So the paper is dropped. You don't have to write any paper. So I'm going to distribute that portion of the percentage to everything else equally. Do you have a question? Oh, that's 14. So today is the last day of May, right? So you have about 2 weeks. What else? Oh, tomorrow. There's a quiz, right? As you know, I have some suggestions. But the main topic is chapter 6 and 7. Okay? So you have a few things to know. And I'm going to ask them. It'll be about 30 minutes. So after 30 minutes, once you're done, then you can go. You can leave. I don't expect that you really need all 30 minutes to solve that 2 questions. It's kind of simple. It's not very hard. But you got to be prepared. So again, the best way is to redo homework 8, 9, and 10. If you know how to solve each one of these questions, then you should be really fine. Okay, so hopefully today we finish this last topic together. Okay, and let's see what else we can do. By the way, you can help each other. Okay, so for example, you kind of walk as your group, and then maybe you can compare your answers to other group. That's perfectly fine. So the goal is to present the best possible solution to the entire class, okay? Can I erase it? Now, suppose that we have a multiple regression and want to test a hypothesis like this, okay? Beta 1 is equal to beta 2. Just one example. And I'm going to give you a different example later. So when you have a testing problem, the first thing you have to think about is Q, which is number of restrictions under the null hypothesis. So what is Q in this problem? How many restrictions do you have? Now when Q is 1, you use a t-test, right? So when Q is strictly bigger than 1, you use f-test, right? If it's equal to 1, it's either t or f, and they must be the same. So that's one of the homework exercise, right? In homework 10, you solved a question like that. The p-value must be exactly the same. So the question is how to test a hypothesis like this. So there are 2 methods. So this is how it works. So from the equation, I'm going to subtract this quantity, and I need to add it back, right? Because I've subtracted, I have to cancel it out. So after cancellation, it becomes the original equation. So that's equal to yi, because in fact, I didn't change anything. Right? So you collect terms. So you define new quantities. And you can rewrite it. Now the key point is this. So y is a part of data. X1 is a part of data. W, which is sum of x1 and x2, can be calculated from data. Right? So if you have y, x1, and w, you can run a regression. In fact, this is how you run a regression. So that's possible, right? It's feasible. Now, once you run a regression, you realize that then you're going to have a prediction like this. Then you can apply a t-test as usual, t-test that you know. Okay, so in this t-test, the numerator is gamma hat, and the denominator is the standard error of the gamma hat, which is a part of our outcome. So once you run this regression in R, I produce gamma hat and its standard error, right? So in a way, this is a t-statistics for a hypothesis like this. Agree? So if you run this regression and you ask, is gamma equal to 0, meaning that is x1 any useful to predict y, then you're going to run this simple t-test, right? Now, when gamma is equal to 0, that means that the difference is 0. So this is equivalent to right? So this hypothesis is the same as this hypothesis, which is what we like to test. So t-test for gamma is the t-test for this hypothesis. So how to actually do it? If the t-value is bigger than 2, less than minus 2, you reject this hypothesis in favor of the alternative. If it is between, you fail to reject. That's just the usual t-test. Okay? So this seemingly difficult question can be reduced to the question you already know by manipulating equations. So that's the first method. You got it? So the idea is that you manipulate the equation such that you can reduce this new equation to answer the original hypothesis. So that's the first method. The second method, so again, this hypothesis is exactly the same as this hypothesis, and gamma is the difference between two. Then you can imagine that if you have gamma hat, the standard error of gamma hat, then you can simply calculate the t statistics, right? You can go from there. Now let's think about this question without manipulating any equation. So suppose that you just run an original equation with x1 and x2. Okay? Then you're going to have beta 1 hat and beta 2 hat. So that's how you find out the gamma hat. So that's easy. What is hard is to get the standard error. So standard error of gamma hat is standard error of because gamma hat is equal to difference in two hats. And the standard error is just a square root of the variance. So once we know how to calculate the variance, we are done. Which is kind of easy right now, because we have done this many times. Now we have two random variables, and we need to calculate the variance. So how to do that? It's like variance of x minus y. And what's the last term? So we have sum of two variance. We have covariance, right? We have 2 times covariance. Now, in the R session today, I'm going to show you how to get this variance, two variances, which is kind of easy, you already know. So from the R output, you have standard error of beta 1, right? So if you just square them, it's going to be the variance. You can get these two variances. It'll tell you how to get the covariance. So once you find out these three things, you can calculate the variance of gamma hat. Take the square root. That is the standard error that we're looking for. So we have gamma hat and it's standard error. You can calculate the t statistics easily. Okay? Again, how to make a conclusion? If this t value is bigger than 2 or less than minus 2, you reject the null. Okay, so that's the second method. So you either manipulate the equation or manipulate the t statistics. So you can choose whatever you prefer. Okay? If you are kind of more, kind of person who prefers the calculation, then you can do this. Or if you find it easier, you manipulate the equation and run a different regression, then perhaps you can use the first method. Okay, so that's how you do it. So I just present two methods. Let me give you a few exercises, and we'll do it together, okay? As practice. Can I erase this? So try both methods, okay, for this hypothesis. So how do you do it? So try it. So maybe it's harder than I think. So let me just keep it easier. So the first example was when beta 1 minus beta 2 is equal to 0, right? So let's just change the sign. And let's see how we do it. Manipulate equation to get the answer. So previously in the first example, we subtract and add it back. It's not going to work, right? Because we're not going to get this expression. So this time, we have to add it first, and then we want to subtract. Did you do this? And we have plus, as we want it. Now, we have minus x1 plus x2. So x2i minus x1i. So gamma must be defined in this way, and we have to change it. 2i minus x1i. Again, the same point holds here. x1 is given in data. W can be calculated from the data. So you can still run this regression and get gamma hat and apply the t-statistics. Okay? That's how you do it. So we will have an R session to do it. What about this? So gamma hat is the sum of these beta hats. And the standard error is the standard error of this thing. So the only difference is you have plus, right, in covariance. That's how you get the standard error. So let me make it a little harder. So how do you do it? So adding beta 2 times x1 didn't work, right? So what did you add? 2 times. So you have subtract 2. So they still cancel out. It's as if you didn't do anything. You have 2 here, and you have 2. See, right, over there? So gamma is going to be beta 1 plus 2 times beta 2. And W is going to be x2 minus 2 times x1. Is it right? Again, this is a new parameter. x1 is given. W can be given because x2 is in the data. x1 is the data, so you just calculate this new variable. Run the regression. Apply the t-statistics for gamma. Okay? Now gamma hat is beta 1 hat plus 2 times beta 2 hat. And same for standard error. When you calculate variance, you got to be careful because there is a 2. Now you need 4 and 4. Did you get it? 4 and 4. Okay. Now let me give you something else. This one is harder. Why don't you try it? So the fact is that we just need this expression, right? And we are going to call it gamma. So let's just write down what we want. This is what we want, right? Now what is added, actually subtracted, is beta 2 times x1 and 2 times x1. Right? They should be canceled out. And then we just write down the remaining term. Because we already have experience, let's just call it gamma. Okay, so the whole thing is gamma. Now, for these 2 terms, we can put it together. Now, as you can see, this is gamma, and this is going to be Wi, right? So you have like almost what you want. One problem is this. So somebody said that it doesn't belong here, right? Because there's no regression coefficient. There's nothing to estimate. It actually doesn't belong here. It's just a data, 2 times 1 variable. So when it does not fit on the right-hand side, it may fit on the left-hand side. So it's like I just call this thing yi tilde, kind of new y. Okay. Again, the point is this: this new dependent variable can be calculated from data. So you can define it, and x1 is from the data. W can be calculated from the data, and you can run the regression. Tilde. This regression produces a t-statistics for gamma, and that's the t-statistics you're going to use, okay? Now, did you do this too? Do you need more time? Let me give you 1 more minute. So why don't you try the second method? So gamma hat should be, right? And the standard error should be so our job is to calculate the variance, and then we are going to take the square root. Now this is the time you apply the law of variance. What happens to -2? It's gone. Right? But it doesn't disappear over here, right? So you got to be careful. And then you just take the ratio. There's a t-statistics. Is it clear? Do you have any questions? In the textbook, after chapter 7, there are more exercises. Okay? So just try them. Now think about this. We spent the entire class, the whole day, to do this at the end of the semester. What does it mean? It means something, right? Okay, so think about it and have enough practice. Okay, so let's have another session. So in my lecture notes, I actually used the data that you know very well, the CPS data, to give an example. So let me change things a little bit. So like before, we are going to generate data, okay? So in the spirit of simulation. So I'm going to generate X and Y and things, and then we are going to apply this t-test, okay? So can you type it? So suppose that the sample size is 100. x1 is generated from a normal distribution. x2 is from the uniform distribution. So if you just type them, just a bunch of numbers, okay? So that's how I did for x1, how I did for x2. The error is from the normal distribution. And finally, the regression function looks like this. 1 plus 2 times x1 minus 1.8 times x2 plus u. So that's our model. So in this example, we pretend that we exactly know how the y, the dependent variable, is generated, created, right? So in some sense, we kind of know the answer. Beta 1 is 2, beta 2 is minus 1.8. Okay, so that's the benefit of running simulation. You know the answer already. Now, let's run regression. So don't be confused. We actually know the true value of the regression coefficient, but from this slide, we pretend that we don't. Okay? Although, the back of my mind, I actually know the answer. Now, suppose that we don't know the answer, then you can run this regression with 2 axes, and of course you can do so individually you have the standard error and you have the t-statistics, right? So we can do a simple t-test. Now, what if the question is, are they sum to 0? Suppose that that's the question. Okay? So it is our second example. Now apply method 1 and do it in R. Manipulate the equation. Which simply means that you define new variables and run the regression, right? Take a look at your note. It's a second example. x2 minus x1. And then you run the regression of y on x1 and w. Right? So that's something we remember. And you put it in the summary function. Now, what is the t-statistics we are looking for? That's the t-value for gamma, which is the regression coefficient for x1, right? On this manipulated equation. So t-value is 1.76736. So you're going to reject this hypothesis. You're going to reject it. T-value is less than 2, between minus 2 and 2. So you fail to reject it. Okay? So there is no strong evidence to go against this statement. Is it confusing? You want to try on one more thing? Okay, let's do that. Now try this. So why don't you apply the first method and test this hypothesis? So it's not really different. So when you subtract and add it back, you have to do this manipulation, right? Because you're going to add 1.5 times beta 2 times x1. So you add it, and you have to subtract it back. So that's OCW. So the t value is minus 0.368. So we are going to not reject it, fail to reject this hypothesis. Okay. So this is the first method. Now let's go back to the simpler one. And let me show you how to calculate the standard error directly and t statistics directly for gamma. Okay. Okay, so this is the summary of the original equation. Let me just write it down. I don't want you to be confused. So gamma hat is standard error of gamma hat is square root of then you take the square root. Okay? So what is gamma hat? So G. So that's beta 1 hat plus beta 2 hat. So we calculated gamma hat, right? This is just one way to do it. So if you don't want to write the whole thing, then you can just type coefficient of A, and gamma hat is going to be the sum of these two, right? So A coefficient second is A coefficient third to give us the answer. Again, you get the same answer. So this is the easier part. How to do this? So how do you find these two variances? That's from the standard error. The standard error of x1 is the square root of the variance, beta 1 hat. So this one is a squared standard error from there, and same for that. Okay, so you take the standard error and you square it. So where is the covariance? Anybody remember a function that produce a variance covariance matrix? All the beta hat. What? VCOV. So again, this is another way to get the variance and covariance. So this is the variance of beta 0 hat. We're not going to use it. This is the variance of beta 1 hat. So this is second way. This is variance of beta 2 hat. And the covariance is here. So standard error is variance of beta 1 hat, variance of beta 2 hat, plus 2 times covariance, minus 2 times oh, I forgot something very important. We have to take the square root. Now your t value is gamma hat divided by its standard error, and t statistics is 1.73. So that's exactly the t statistics we got from our first try, right? For the first example. So what's the conclusion? You failed to reject. Okay, so why don't we just do it, okay? So let's try. So what can be a good hypothesis? Beta 1 plus beta 2 is equal to 1. Okay? So just as an exercise, why don't you apply the second method and get the t statistics for this new hypothesis? So why don't you do that? So gamma hat will be different, right? For sure. What about standard error? Remains the same. Right? So we are going to recalculate the gamma hat. But there's no change in standard error because minus 1 is just irrelevant. And you calculate variance. So again, we failed to reject the hypothesis. Okay, so I'll see you tomorrow.